Hello everyone. Today I'm going to discuss the fourth problem of Leetcode Weekly Contest 325, which is number of great partitions. So what is the problem? So we are given an array nums consisting of positive integers and an integer k. Partition the array into two ordered groups such that each element is in exactly one group, and a partition is called great if the sum of the elements of each group is greater than or equal to k. So what is the problem? So we are given some array, let's say e1, e2, an. Now we have to create two groups from that. First one is, let's say, red group, and the second one is, let's say, green group, and each of the element could be either in first group or in second group, but not in both the groups. So we have to just split that into two parts, two subsequences. And okay, now what is the constant? So the sum of this group is also greater than equals to k, and sum of this group is also greater than equals to k. Now let's consider one example. So first is 1 2 3 4 and k equals to 4. So a is 1 2 3 4 and k is equals to 4. So what could be the valid partitions? First one is, let's say, let's consider only the first group, because let's say we have put 1 and 3 here, then the rest of the elements 2 and 4 will be here. So if we only create one group, then the other group will automatically be formed. So let's say first case 1 3 2 4, this is a valid example, and the second case is 1 4 2 3, this is one valid case. Now let's take something else also. 1 2 3 1 2 3 4. So this is three possible conditions, but why the answer is 6 here? Because we can interchange the red and the green groups. So let's say 1 3 2 4 could also become 2 4 1 3, and they would be different answers. Okay, so the answer is 3 into 2 equals to 6. Okay, I hope you understand. Now let's jump into some observation, or how I have solved the problem. Okay, so let's clear all this stuff. Now let's go into some observation. So what is the first observation? First observation will be always be the constants. So here you can check that nums length and k is less than equal to 1000. Okay, so uh, n and k is less than equals to 1000, but ai is less than equals to 10 to the power 9. So the first thing you might observe is that we can do some kind of order of n into sum. Order of n into sum is what? Order of n into sum is what we call it? It is called sum over subset problem. So we will construct dpi and sum, which means that the count of subarrays with sum equals to sum. Okay, so let's say 1 2 3 4, and we are constructing the sum over subset problem. So dp1 comma 1 will point out that number of subsequences ending at index 1 with sum equals to 1, so it will be 1. Now let's say 1 I equals to 1 and sum equals to, say, I equals to 2 and sum equals to 2. I equals to 2 and sum equals to 2 will be only this, so it will also be 1. Then now let's say I equals to 2, I equals to 3 and sum equals to 3. So there could be either two possibilities: either we can take 1 2, or we can take this 3. So the answer will be 2. So I hope you understand what is dp I sum. I sum means the number of subsequences ending at index I with the sum equals to sum, or you can say this as j also, with sum equals to j. Okay, I hope you understand. But here sum is what? Here sum is the sum of the elements, but ai is 10 to the power 9. Ai is 10 to the power 9, so this is impossible, because we will have some space complexity issue, and time complexity issues also. Now another thing you might observe is that k equals to 1000. Okay, so let's delete all this thing. So now the second observation you might have is that k is equals to 1000. So now each of the element, let's say ai equals to ai greater than k, so we can just change this ai greater than k to ai equals to k plus 1, because if we take this ai in any of the group, in red group or green group, the sum will always be greater than k, greater than equals to k, or you can just take ai equals to k. Okay, ai equals to k, and if you put in into the green container or red container, it will give us sum greater than k. Okay, this is the second observation. So the second observation is we have made. ai equals to minimum of maximum minimum of ai comma k. This is the second transformation. Now every element of a comes to 0 to 10 to the power 3. This is the second observation. Okay, 0 to 10 to the power 3. But what will be the sum? The sum of the elements will be n into ai. So n is equals to 10 to the power 3 and sum will be 10 to the power 6. Now our SOS problem is of what complexity? Our SOS problem is of order of n into sum. So our overall complexity will be 10 to the power 6 into 10 to the power 3, which is order of 10 to the power 9, which is also not possible. The time and space complexity both not possible. I hope you got it. Now let's jump into the final observation. The final observation is that, okay, this is the most important observation and the observation which will help us to solve the problem. So let's call it final observation. So the final observation is that the total number of subsequences from an array could be 2 to the power n. Now there are 2 to the power n number of subsequences in the array. Now let's say we have to split the array into two subsequences. One will be sum greater than equals to k and the another one will be sum greater than equals to k. Now let's think of this as the complement problem. So now we have to find, this is greater than equals to k and greater than equals to k. Now if we thought about the complement of this statement, what is the complement of this statement? The complement of this statement will be sum less than k of the red container or sum less than k for the green container, and our answer will be what? 2 to the power n minus f of this, count of this, count of this. So we have changed our problem from the original problem to the complement problem. I hope you got the complement thing. So now let's say our sample place is ns. Now our answer will be, let's say total size is t, then the our answer will be t minus n of s complement. I hope you got it. This is the what we can say, this is the theorem we have uh, used here. This 2 to the power n is our total number of subsequences, and this is the event, and this is the complement event. So now let's write it again. Okay, okay. So what we have changed it, now we have to find the number of subsequences which is less than equals to k, less than k. Okay, so this is quite straightforward. Now jump into the solution. So here this is for power modulo. uh, you can find it in Geeks for Geeks or any other places. This is binary exponentiation with power. Now I have converted every element ai with minimum of ai comma k plus 1. You can also take k here. Okay, this will not matter. Now I have also taken the variable sum. Okay, now here this part is quite trivial, sum over subset, but we are just constraining our sum to k, because what we are doing here, you can just do j less than k here also. Okay, so what we are finding, we are finding less than k number of subsequences with sum less than k. So we don't care if our sum greater than equals to k or not. So here this is quite straightforward sum or subset problem. You can find it in any other places, in Geeks for Geeks, in YouTube, and here we are just finding the answer, which is power of 2 to the power n. Okay, 2 to the power n here. Now this is the quite interesting part here. Now let's consider this part is important. So let's consider we have found a subsequence, let's say s, which has sum less than k. Okay, and that rest of the sum will be sum minus s. Okay, sum minus s. Now if sum minus s is less than k, we cannot shuffle, because we will also have sum minus s in our as s. Okay, I hope you got it. So we are iterating on s which is less than k, and sum minus s is also less than k. So we can't shuffle s and sum minus s. But if sum minus s is greater than equals to k, then we can shuffle this sum minus n and s. So what I have told earlier is the red and green container logic. So let's dive into that as well. Let's say this is s and this is sum minus s. Okay, now if sum minus s is greater than k, we can shuffle it into the red container and this into the right green container. But if sum minus is less than k, we can't do that. Okay, that's why here I have multiplying dpni into 2 if sum minus I is greater than equals to k. So I hope you understood. uh, Sum minus s is less than k. So let's take one example to solve this. Okay, so dpni. Okay, so let's say 1 2 3 4. Let's take this example only. 1 2 3 4. Now our red container will have and green container. So let's consider k equals to 4. Okay, now we have put 1 2 here, and the sum will be 3, and the rest of the sum will be 3 4 7. Okay, 7. Now we can shuffle this also. So we can put 3 4 here and 1 2 here. So we are multiplying this by 2. But let's say our k equals to 8. If k equals to 8, we can't shuffle 1 2 and 3 4, because there will be one case, because we are counting the subsequence, there will be case where 3 4 is in the red container eventually. I hope you got it. There might be some doubts. Please ask me in the comment section. If you don't like the video, please give some positive feedbacks or constructive criticism. I will try to develop this in my next videos also. Please like the video if you are helpful from this video, and subscribe to the channel.